All right, 5.1 touches on just some general things about randomness that we can touch on that might be asked about, and then also some things with simulating and simulation of probability. So first, a couple of big ideas. One is that randomness is predictable in the long run when we're talking about probability. So chance behavior is unpredictable in the short run, but has a regular and predictable pattern in the long run. The law of large numbers states that as the number of repetitions of a chance process increases, the proportion of times a specific outcome occurs approaches a single value. And then when you put those two ideas together with this, what we call the probability of an outcome of a chance process is that number from the law of large numbers. It's a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. So that's a lot of writing, but it basically is just describing what really is happening when we talk about probability of some random phenomenon. Like if I'm going to roll a die, roll a number cube, the randomness means that I don't know what I'm going to get from trial to trial to trial. But the law of large numbers says if we kept rolling over and over and over and over again, the proportions that we get for each of the different sides are all going to settle out, in the case of a number cube, to 1/6 for each side. That 1/6 is what we're calling the probability. Here's kind of a visual example that's shown a lot. If you are looking at flipping a coin, and we look at the proportion of heads in the first 20 tosses. If the first toss is tails, then we've had 0 heads. That's why the first dot is down here. Then if we get a heads, the proportion of heads jumps up to half. We're exactly at 50-50 like we'd expect. But then if we get tails, 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 our proportion of heads is now dropped because of the randomness, because of the unpredictability. And so as we keep flipping, if we got heads, we see it jump up. Another tails causes it to drop down. Then we get a string of heads that actually puts us up and over 50% now for heads. And that'll keep cycling back and forth as we keep track of flips. But eventually what'll happen, so here's an extended now looking at 500 tosses, we might see a lot of fluctuation earlier, but eventually it's going to start settling out where eventually we're going to be almost indistinguishable from 50% if we flip enough times. So we would predict that after a large number of coin flips, and large meaning very, very large, the proportion of heads would be 0.5. So then let's talk about the myth of the law of averages. This is where it's sometimes called the gambler's fallacy. A TV weather person says that since we have had mild winters the past few years, quote, we are due, quote, unquote, for a colder winter because of the law of averages. That is not a thing. Probability does not have a memory, so that probability doesn't know, I got to keep things even and adjust. Or if you've had 3 boys, then you must have a girl the next time. It's again, probability doesn't have a memory. Or playing craps. Here's the one where gamblers really get into trouble. You've had several wins in a row, so you've had a hot hand, so you just keep winning. Or if I've been losing a bunch, my luck's got to turn around, so people keep playing and losing more money. Okay, a simulation is an imitation of chance behavior most often carried out with random numbers. And we are going to use a table of random digits to do our simulation. So let's say Carl makes 75% of his free throws. Before, when we used a random number generator, it was to select a sample. Now we're going to use the random number table below to simulate 10 attempts. To use random numbers for simulating probability, we need to assign digits to stand for either making or missing. So here's so we can assign digits in any combination so that 75% of our digits would count for making and 25% would count for missing. So here is one combination that would work. If we do 1, 2, 3, 4, 5, and 6 as a make and 7 and 8 as a miss, we would have to skip 9 and 0. If we come across any single digits of 9 and 0, we would skip them. But then that gives us 6 out of the 8 digits we are using. Get that up here. Count as making, so that is 75%. We have 2 out of our 8 digits as a miss, so that is 75% make, 25% miss. Okay, this is a different combination, but it would work just as well. If I do 1, 2, and 3 as a make and 4 as a miss, then I have 3 out of my 4 as a make and 1 out of my 4 as a miss. That is 75% and 25%. We would just have to skip more digits. I could also do 2-digit numbers and do 0, 1 to 75. That is 75 digits. And 76 to 00 as a miss, and that is 25 digits. So that would work, and we wouldn't have to skip anything. So there's different ways you can do it. Probably the biggest difference here is we don't care if there are repeats. All we are using the random digits for are to decide whether we had a make or a miss. And so we're just going to keep going. So like if I want to do 10 free throws, I just need to look at 10 pairs of numbers. Okay, and let's say we're going to use this last combination here. Anything that's 0, 1 to 75 counts as a make. So my first 2 digits are a 19, that's one make. My next 2 digits are 22, that is still between 0, 1, and 75, so that is a make. Then I have 39, that's 3 makes. I've got 50, that's 4 makes, so we're on a hot streak, quote unquote hot streak. 34 is between 0, 1, and 75, so that's a make. 0, 5, that's our 6th make. 7, 5, that's still barely a make. We made it in there, so we're at 7 right now. 62 is still a make, so we're at 8 out of 8 right now. 87 would be our first miss. And then 13 is still between 0, 1, and 75. So if we use that first row of numbers, we would actually end up with 9 out of 10. We made 9 out of 10. Okay, if we use a different line though, let's say we start down below here. Let's say we start in this line. We start off with a miss. Then we would have one make. Then we would have another make. Then we would have another make. That's our third make out of 4 shots. Our fourth shot would be a make. Our fifth shot would be a make. Then we would have a miss with the 97. So right now we have 1, 2, 3, 4, 5 makes, 2 misses. Then we would have another, oops, wrong one. We would have another made shot, then another made shot, and then our last one will be a miss. So in this case, we would end up with 7 makes out of 10. And it's not that any version is right or wrong. We're just using this as a way, instead of actually carrying out free throws, a way to measure different things that could happen. We are simulating the real event with these numbers. So we already talked about it, this top part. Now let's say a local VFW runs a raffle contest and claims that 1 in 5 wins. Another type of question you might see is like this. Which of the following are possible ways to assign digits and use a random number generator to simulate a sample of 15 raffle tickets? So now they're wanting to know which of these combinations would work. So if I do 1 is a win and 2, 3, 4, 5 is a loss, that one would work. Because I do have 1 digit that works, and 2, 3, 4, 5 is 4 digits, so 1 out of 5 digits, and that is 20%. Next one I have 1 and 2 is a win, so I have 2 digits that count as a win. Then I have 3, 4, 5, 6, 7, 8, 9. That's only 7 digits, so this would be 2 out of 9. This one does not work. Because we don't have a 20%, we only have 2 out of 9, which is like 22.2%. So then if we look at the next one, they're going to count 0, 0 to 20 as a win and 21 to 99 as a loss. Well, this is another one that does not work. Because if we take 0, 0 to 20, that's actually 21 digits. And then we're doing the rest as a lose, so that would actually be 21 out of 100. That does not hit our 20% mark of 1 and 5. And then the last one is pretty similar to the first one. We used a different digit, which is fine. It doesn't matter if we use a 2 as a win, but we still have 2 digits. Or sorry, the digit 2, so 1 digit that counts as a win, 5 digits total, so 1 out of 5 that would count as our, would work for our 1 in 5 wins. So a simulation is an imitation of chance behavior, most often carried out with random numbers. And then the note that I mentioned above, repeats are allowed. The numbers, when we are looking at the numbers, all we're doing is looking whether that number falls in the success or fail part of a trial. And then that's what determines, and we just move on. If we get the same number twice, it doesn't matter. It doesn't matter. We don't have to skip it. We just look and see if that counts toward success or fail. So for example, in the basketball example, let's say the first few digits were 56, 56, 78, 82. Well, that would end up being 2 makes and 2 misses. It doesn't matter that these are both 56. I'm only looking at this and saying, oh, 56 falls into the make category. So I would have a make, I would have another make. Maybe I have to do it this way. So we would have a make, we would have a make, then we'd have a miss, because 78 is bigger than, it's 76 to 100, then we'd have another miss. Doesn't matter whether it's a repeat or whether it's not a repeat. We just categorize it as a make or a miss. All right, that should do it. There's some questions that follow up this video in that same folder. Give those a shot when you think you're ready.